The first thing I want to start off with is maybe just a little bit of like terms. All right, do you know what like terms are? All right, let's go through that concept. All right, so the concept of like terms is basically surrounds the fact that if you have the same letter, there is two important properties. Like terms have the, in layman terms, the same letter and same power, or same arrangement of letters and same powers as well. An example of this would be if I have x plus x, it'll equal 2x. Or x plus x plus x will equal 3x. But x plus x squared stays the same. So we can't really go any further than that because these are not like terms. Okay. And then you can have the concept of where you have x plus y plus x plus y. In this case, you can end up with 2x plus 2y. When you keep the x's together, keep the y's together, and you end up with that. Cool. X squared plus y squared plus 2x squared will be x squared plus 2x squared gets you 3x squared, and then y squared at the end after that. Okay, all right. So I got 3x squared plus y squared done. Can't go further than that. If I have now a combination of this, same arrangement of letters, so xy plus xy will equal 2xy. And let's say x is orange juice. And let's say y is water. Let's say it's orange juice concentrate. And y is water, and together it becomes orange juice. So one orange juice plus one orange juice will equal two orange juices, where you silently multiply them in there. Okay, and xy can also become, let's say, x squared y, and this would be a recipe where you have two parts x, so two parts of orange juice extract, plus one part of water, and if you add it with xy, it won't mix, because this is a different juice. This one is going to be slightly stronger. So they won't mix, so they're not like terms as well. And looking at that concept, what would mix with this is if I had x squared y plus x squared y, then that will become 2x squared y. So it's exactly the same juice, but two of them. All right, building on that idea, we get another long one. Let's say that xy plus x squared plus x squared y plus 2x plus 3y squared plus 4y minus 6xy squared. Believe it or not, none of these terms are like terms. They're not like terms completely. There's not one term that's the same like the other. The reason is, if it's x, it's connected to a y, or it's a different power. And these two look similar, but they're actually different. The one has squared on y, the other one has squared specifically on x. Then you got the coefficient here, which is 1, the coefficient here, which is 6. Still can't add it anyway. It's not about the coefficients, it's about the letters. And then y is not the same as y squared, that's a different power. X is not the same as x squared, different power, and these two are combined. So we can't do anything in this question. In this question, that is the answer. If you get given a question, which you probably won't on this level, that would be the answer. But now let's change it into something that looks like that. Let's suppose I've got xy plus x squared plus xy plus 2x squared plus 3xy plus 4x squared minus 6xy. I'm now going to gather all the like terms. So I see xy, there's a combination of xy with the plus which belongs to it, and the minus belongs to the 6y, so that would stick together. The plus would stick together as well as that. And now I'm going to add these together. Taking the coefficients into mind, this invisible coefficient here and over here is actually 1. Alright, so 1xy plus 1xy will become 2xy. That's like 2 orange juices with 1 part concentrate and 1 part water. Plus 3xy would be 1 plus 1 plus 3. 1 plus 1 is 2, 2 plus 3 is 5. And then 5 minus 6, we're now going to look at integers. If I got 5 and I'm minusing 6, it's going to be negative 1xy. Alright, let's go to x squared now. Plus belongs to the x squared, plus belongs to the 2x squared, and plus belongs to the 4x squared, all pluses, so imaginary, don't forget invisible, 1. 1 plus 2 is 3. 3 plus 4 is 7. So it becomes 7x squared. And I'm done. And I can rearrange it so that the negative is in between. So this can be rewritten as 7x squared minus 1xy. And we normally don't even worry about the 1. We can actually just write it as 7x squared minus xy. And that all means the same thing. So this is exactly the same as that. And this is exactly the same as that. And what we have over here now are like terms. What you're also noticing is that between these two pages, we are also adding and subtracting. So we're doing pluses and minuses for these two. Pluses and minuses. Now let's look at a little bit of multiplication and division. Let's bring some multiplication and division in with a little bit of algebra. Let's look at x times x, x times y, y times y, x times x times x, x times x times y, x times x squared, y times y cubed, y times y squared times x squared, and let's say x to the power 4 times x to the power 17 times y to the power 19. This is just multiply, not divide. Let's have a look at those. When you have x times x, the power is an imaginary invisible again, 1. So we have invisible powers. What we do is we silently add the powers together, which we can skip this step, and we can go straight to the answer and go x times x is x squared. X times y, x, y. Y times y, invisible 1, becomes y squared. So what does this mean? This means that whenever you have xy together, the times disappears. So you can also put a dot in between the two, or you can just write xy, which means multiply. This one will be y squared, 1 plus 1. Here we've got 1 plus 1 plus 1. Oh, we got 3 x's, so x to the power of 3. Before we continue, let's just make sure we understand the following. If I've got x plus x plus x, this is equal to 3x. But x times x times x is equal to x to the power of 3. So here we add the powers, and here we add the coefficients. So we must remember when we multiply, we're dealing with powers, and when we add, we're dealing with coefficients. The number in front of a variable is known as a coefficient, whatever number's in front. All right, let's go back there. X times x would be power 1, and it'll become x squared. And y times y would become y squared. And then you can remove the times, just write x squared, y squared. All right, so that would be that solution. Okay, does that all make sense so far? Yeah? Okay, good. Let's finish up the last few. So this is going to be x to the power of 3. 1 plus 3 is 4. Bring the y's together first for this one. Then bring the x's together for this one. And I got y cubed x cubed. We normally write it the other way around because x comes first alphabetically, but that's just how mathematical terms are normally written. So we would write that first, but it means the same thing. The next one, we got two x's which are the same, the y is different, so we can only multiply the x's, which means we technically going to ignore this and just rewrite it after this. 4 is going to add to the 17 to become 21. So that's x21 to the power of 21 times y to the power of 19. You can put a dot in between and just write them together. And that's it. We just rewrote that second part over there. And that's how we get up there. Now, before we move on to division, let's do a little bit of a practice session. Let's do a little bit of a practice session. And let's say I give you maybe 4, 5, or 6 questions. Let's see. So maybe grab a page. You're going to try it. I'll just go through the answers afterwards. So I won't ask you if you're correct or incorrect. I just want you to try it. So, and then you can just mark it afterwards as well. All right, here we go. So question 1, I got x plus y plus x plus y. 2, 2x plus 17x. 3, 3x squared minus 4x plus x squared. You can keep going, I'll just be present. All right, let me know when you're done. Take your time. All right, I'll write you. Yeah, that's what I'm going to do as well. So I'm going to, yeah, as soon as you're just going to try this for 5 minutes or 2 or 3. Yeah, go for it. So x plus x will become 2x. Y plus y becomes 2y. So that becomes 2x plus 2y. 2x plus 17x will get you 19x. 2 plus 17 is 19. For the next one, 3 plus an imaginary 1 becomes 4x squared. And then simply minus 4x. We can't go any further than that because the terms are not like. For the next one, these two terms are like, so that will become 3xy. And then these two terms are like minus imaginary 1, minus 1 plus 2 is 1, y squared or plus. So 3xy plus y squared. For question 5, I got x plus x, which will get me x squared. and then y plus y plus y will become y cubed. So I got x squared times y cubed, which will become x to the power of 5 over. Okay, now next, x squared plus x cubed becomes x to the power of 5, and then y squared will be like that. All right, which one did you struggle with? Any one of these that you want to do more? 3 and 4. Okay. I've got x divided by x. Because the powers are the same, we say that we're going to subtract the powers, and we take the top power first, and we subtract the bottom power. When we multiply, we add the powers. When we divide, we subtract the powers. This becomes x to the power of 0. So we might as well look at that. Anything to the power of 0 is always equal to 1. And we know. So if you have x to the power of 0, then this will become 1. Yeah. It's like 2 divided by 2 is 1, 3 divided by 3 is 1. So if you get x divided by x, it's also 1. But if you have to, there's a hidden step there, and that hidden step is this one here. So let's look at another example. Let's look at x squared over x. This is going to be x to the power of 2 minus 1, which is x to the power of 1. X to the power of 3 over x is the same as power of 1, so this becomes x to the power of 3 minus 1, which is x squared. If you have x to the power of 3 over x to the power of 2, then this will be x to the power of 3 minus 2, which is x to the power of 1. And x to the power of 17 over x to the power of 15 will be x to the power of 2, because 17 minus 15 is 2. And you can go straight to the solution once you get there anyway. What happens when the power at the bottom is more than the power at the top? Then in this case, it'll be 2 minus 3, which is actually minus 1, which is actually bringing x into the denominator and writing 1 at the top. But let's look at another one. Let's look at x squared over x to the power of 4. X to the power of 2 minus 4, negative 2, goes to the denominator, becomes x squared, and 1 at the top. Now, let's go to one more of these. If I've got x to the power of 3 over x to the power of 5, another way to look at this would be like this. This is the same as x times x times x. It's 1 plus 1 plus 1. And this is x times x times x times x times x 5 times, because it's 1 plus 1 plus 1 5 times. Which means when we cancel out these, we'll be left with an imaginary 1 at the top and x squared at the bottom. So we can call this one we call this method number 2. Method 1, x to the power of 3 minus 5, which is x to the power of negative 2. Bring it into the denominator, make it positive, and then put 1 at the top. So method 1 of division, method 2 of division, you can choose either one. All right, no problem. What I'll do is I'll just keep that there. Let me know when you're done with this one. Okay. No power means that you have to have an imaginary power. So in this example, we're dividing different letters, different powers, but you notice that the top power is bigger than the bottom power for each of them. So this is 1, this is 1, and this is 1. We can simply just minus it And we can put an imaginary step in our mind. We can do this, or we can write it down. X to the power of 3 minus 1 gets me that part done. Multiply by, I'll put a dot, which means multiply. 4 minus 1 and 3 minus 1 for z. 4 minus 1 is, did I say 4 minus 1? Yeah. And then z to the power of 3 minus 1, which I can then simplify to become x squared, y to the power of 3, z to the power of 2. Yeah. I can do that. I can go straight from there to the solution if I can see quite clearly. Reversing this entire process around basically will end up as the following. So if I've got, let's suppose I've got x to the power of 4, y to the power of 3, and z to the power of 2, and I have x to the power of 1, y to the power of 1, and z to the power of 2. In this case over here, I've got the top power is less than the bottom power. So I can minus upwards, or I can rewrite them all together. Get negative powers and then maybe bring it into the denominator. So 1 minus 4, let's say I don't put a line yet, 1 minus 4 times 1 minus 3 times 2 minus 2, x to the negative 3, y to the power of negative 2, z to the power of 0, and then I bring all of this into my denominator. So I'm going to put this over 1 for now. I'm going to bring all of this into the denominator for this, and then last step, which I can skip a few steps to understand this. So this is going to go into the denominator. It's going to become x to the power of 3, positive 3, y to the positive 2, and z to the power 0 is 1. So I don't have to worry about that. So this is going to disappear. And I'll be left with that. Let's go through the process one more time. All right, so there's the question over there. Step 1, prove the x's 1 minus 4, prove the y's 1 minus 3, prove the z's 2 minus 2, negative 3, you don't forget your integers, 1 minus 3, negative 2, and then 2 minus 2, which is equal to 0. Now, put this in a fraction form and bring everything down. This is going to become x to the power 3, y to the power 2, that becomes 1, and 1 at the top. When there's nothing at the top, the numerator becomes 1. Alright, I'll give you a second to then write something here if you need to, or we can just jump into a few questions if you want. Is that okay? Are you sure? Alright, cool. Next. Alright, here we go. Get ready for this one now. Okay, here we go. I've got x to the power 3, y to the power 4, z to the power 2 over x squared, y squared, z squared. I've got x to the power 3, y to the power 5, z to the power 2 over x, y, z. And now I'm going to reverse it. X squared, y squared, z squared over x to the power 3, y to the power 4, z to the power of 4. I've got x, y, z. I've got x to the power of 4, y to the power of 3. Let's make this 1, 2. Maybe let's make that 3. And z to the power of 5. Okay. Can you read all the numbers that's there at the moment? Okay, cool. Can I leave you for a second? Alright. Okay, so those are the solutions there. Subtracting down, 3 minus 1 gets me 2, 5 minus 1 gets me 4, 2 minus the imaginary 1 gets me 1, And in this one, you're also subtracting out, getting those 4 and 6.